Oh hey, hi guys, welcome back to the shop. So I know how you guys love these product reviews, so let's mix this one up a little bit. So we've got a VFD drive here from Vevor. Haven't even opened it yet. So let's do a review on it, put it through its paces, and then for something a little different, let's give it away. I know you guys don't want to see an unboxing, so let's just do that at light speed and we'll get right into it. You get a drive, you get a extension cable for remote mounting the display, and a user manual. That's pretty much it. They do have a nice note here on where your electrical wires go in, with some precautions and reminders of what settings you need to set before you power the unit up. So that's kind of handy for those guys that throw the manual right in the trash as soon as they open the box. Okay, those screws are not captive, so easily lost. I suck at peeling labels off without leaving residue, so it is what it is. Okay, let's take a close look here. So there's our high voltage terminals down to the bottom, control terminals up here. Yeah, that part doesn't look too bad. Now there is no conduit. Well, I guess you could use conduit maybe on that one, but it's not really designed for conduit connection. So this is what we would call an open drive. You would probably want to put it in a panel. And speaking of open drive, so it's got ventilation holes all the way around. Here's your cooling fan on the top, and you've got ventilation holes on the bottom. That's the air intake for the cooling. So you would not want to mount this too close to your machine tools, or metal chips could get in, or sawdust or what have you. You either got to mount it on a wall, out of harm's way, or put it in some kind of a panel. And then if you put it in a panel, you're going to need a cooling fan to give it adequate cooling. I do like having the speed pot right on the front. It's a lot easier than trying to use the buttons to adjust the speed. I was just having a close look at the circuit board and how it's made and so forth, and everything looks pretty nice. There's nothing loose inside, no leftover parts floating around, no tools left behind. So yeah, that's not bad. Now I did try off camera, I tried to remove the display unit, and honestly I don't think I can get it out of there without the possibility of doing some damage. I tried, and there's a button you got to push in, release lever, and it is in there tight. So I don't want to try that. Maybe we'll try it again when we've done all our testing, but I don't want to break it right off the bat. Okay, and then like I said before, everything is plastic. I mean, at this price point, that's what you're going to get. And I'll show you a screenshot of the website with the price. Current price US, I think, is $124. And that's, pretty good for a 5 horsepower VFD, okay? This drive does not have vector control mode. So it's just a standard scalar frequency type VFD, which is the most common way they run. Vector mode is for constant torque, and you need a special motor for that. And most of us aren't going to be running our machines that way, okay? The other thing it doesn't have is the RS-485 communication, so you can't communicate to this drive via like an automation network. We're not going to do that in our home shops, okay? So that's no big deal, okay? And it does not have built-in PID control, so it can't control a fan or a pump to a pressure input, right? So we're not doing that, so that's not a problem. So it's just a, you know, just a basic drive that does what, you know, essentially we need to do, and nothing else. There are a couple things. I've been going through the manual and looking at this thing a little bit off camera. It does not have a connection for braking resistor, okay? So on smaller machine tools, a braking function is probably not that big of a deal. If you had a large lathe with a big chuck and you're spinning some heavy items, braking resistor might be necessary. But for the most part, in my opinion, you really don't need it, okay? It does have magnetic braking, and we'll go over that when we do the test, okay? This one's kind of a big one, okay? So this is a 4 kW, and so that's like 5.5 horsepower, okay? So it has overload protection, overcurrent protection for that rating, okay, for the full rating of the drive. If you're running a smaller motor, like say a 3 horsepower, which is what we're going to be running, this drive isn't going to know that, and I could not find an adjustment to change the current limiting or current overload setting. So that could be a problem. If you have an expensive motor, you would probably want to make sure that you had some type of overload protection, either, you know, fuses or an overload block of some sort that would shut the drive down in an overload condition. So that's kind of a negative in my opinion. But there again, this is a low-cost drive, okay? Yeah, so that's about it. Other than that, it's got what we need in it. Let's continue on. All right, just a quick look at the manual. It's not too bad. I mean, the English translation, for the most part, is understandable. You've got the safety precautions, and I encourage everybody to read those. Okay, here's the layout and your clearances that are required. Everything's in metric millimeters, of course, and your wiring hookup. Okay, one thing to note here. On the single phase input, this is a 230 volt single phase input, and they call it L1 and neutral, or L and neutral. Well, that's probably correct in the UK, but it's not correct here in the US, so it would be L1 and L2. We do not connect to neutral here in the US, okay? So for 230 volt, it's L1 and L2, okay? But it's still the same terminal, all right? And then you've got, you know, forward start stop, reverse start stop. There's a reset input, and then these two are confusing. This is a digital frequency up and a digital frequency down, and here they call it DO plus and D1 minus. Okay, that is confusing because, you know, when you're talking electrical hookups, you're thinking, oh, I need to put a negative voltage or positive. No, this is just plus means speed up, minus means slow down. Okay, if you're using a fast and slow momentary type input buttons. Okay. Other than that, the manual's not too bad. There's not a lot you can adjust on this drive. It's pretty basic. Okay. It does have torque boost, which is good because we need torque boost for machine tools. Okay, and we'll look at that setting when we get there, when we're doing the testing. So overall, not too bad of a manual. Okay, and they show you how to, you know, take the display off. It does not come off that easy. I tried. Okay. Yeah. Oh yeah, and one last thing. There is no input for e-stop, and I looked to see if any of these other inputs can be repurposed or reprogrammed for e-stop, and you can't do that on this drive. But I'll show you how to wire in the e-stop when that's an issue. It's not that difficult. I've moved this over to the workbench, and off camera I took the liberty of hooking up the high voltage wiring. And I'll bring you in closer here in a second and show you that. But we got a 3 horsepower, 3-phase motor, 200 volt motor. We've got our power source hooked up, and I don't think you can see it off camera. I have a power switch so we can turn it on and off without having to run up and unplug our power cord. Okay, so let me bring you in a little closer and show you our connections. I took out this rubber grommet that goes in the connection opening here. Normally you would cut holes in this grommet and feed your wires through, but since we're just doing a temporary hookup here, I didn't want to do that. But for the permanent hookup, you definitely want to use that grommet. Alright, so here's our connections, and everything was fairly straightforward. The motor side, which are these 3, hooked up just like they show in the book. Now we are using a ground wire. Okay, very important on VFDs that you use the ground wires. Okay, so the motor has a ground wire in its cable, and our incoming power source has a ground wire, and they both go on the same terminal typically. Sometimes they'll have separate terminals. Okay, and then these 2 are our 120 volt. Try that again. These 2 are the 2 30 volt single phase input. Okay, now if we look in the book, it shows our single phase input going to L1 and neutral. All right, well, we don't have an L1 and a neutral, but they do have in print down here at the bottom, and it's hard to see there, and they also have it here on this label: single phase input 220 connection R and T. Okay, so it's R and T. Okay, so we got that figured out. Here's the reminder sticker that was covering this opening when we unboxed it. So they recommend that you go in and adjust parameters 2, 10, and 12 before the first time you use the drive. So obviously you have to have the power on to do that, so that'll be the first thing we do. I went ahead and put the cover back on the electrical. This drive has most likely never been powered up since it left the factory, so anything could happen. So better to be safe and have the cover in place, at least on the first power up. Okay, first power up, here goes. Okay, that looks like a speed setting that's flashing. Alright, let's go to that parameter 2 that they want us to adjust. There we go, parameter 2. Okay, set to read the value is 50 Hertz. Okay, we're going to change it to 60, which is kind of strange. They call this the initial frequency. Okay, hit set to enter. 10. Okay, set. Okay, 50. Okay, parameter 10 is the maximum frequency. Okay, whoops. Let's go back. Parameter 10. Okay, set. The timeout is pretty fast if you miss it. We'll start at 60, which is what the motor is, the 60 Hertz motor. Now you can overspeed, and it's rather common to run it faster than the motor nameplate, but we're going to start out with everything matching first. Okay, set. There we go, parameter 12 set is also 50. Now this is the motor rated frequency. So this, you always match this to whatever your motor nameplate is. And in our case, it's 60 hertz. Okay, set. Okay, good. Okay, hopefully you can see that better. So our adjustment knob definitely adjusts our frequency setting. All right, let's start out fairly low for low drama. Okay, 10 hertz. Let's just hit the run button, see what happens. Oh, how about that? So far so good. Crank it up a bit. "37 hertz, 46, 53. There we go, full speed, 60 hertz. All right, not bad. Okay, so that's right out of the box with only changing a couple basic settings. Okay. Let's bring it up to speed and hit our stop button. See what happens. Here we go, stop. Okay, so it's a ramp to stop by default, apparently. Okay, let's try something else. Let me start it up again. We have a forward and reverse button right here on the front. Let's just try slamming it right into reverse. Seems to handle that, no problem. How about if it's going a little bit faster? Go full speed. Beat on it a little bit. Okay, here we go. Okay. I'm going to try different acceleration time. Okay, we're going to adjust the acceleration time. We're looking for parameter number 8. Number 8, okay. Okay, so there's our acceleration time in seconds. Okay, so let's lower this down. Oh, set. Okay, now let's lower it down. And I think you can move the decimal. Let's do that. Okay, yeah, here we go. Let's go, I'm going to go with 4 seconds. Okay, 4 seconds, set. Okay, now we need to go to parameter 9 is the deceleration. Okay, that's what we want. Okay, set. We're going to make it 4 seconds also. Okay, set. That was fine. Okay, now let's hit reverse. It seems to handle it no problem. Okay, and then let's hit stop. Okay. I just changed the acceleration and deceleration to 3 seconds. So let's try that. Run. Okay, no problem there. And stop. Okay. Let's start it again. And let's go straight to reverse. Okay, no issues. Okay, stop. I'm going to go to parameter 6, and this is the stop method for the drive. Okay, stop by itself, which really means coast to stop, or stop by deacceleration. Obviously it's doing that right now. I want to change it to here just to compare the two. Okay, starting up, we're set up for coast to stop. So we're going to compare the difference here. All right, we're up to speed. We're going to hit stop. And the motor's just freewheeling. I know what you're thinking. What happens if you hit reverse while it's doing that? I don't think that's a good idea. We're not going to do that, okay? Next thing I want to look at is torque compensation, parameter 13, okay? So what this is, VFDs that are running in the scalar frequency mode, which is how this one is, they use a lower voltage at lower speed, so you're not getting your full power out of the motor, okay? But they have a compensation that you can adjust, in most cases, to give it a little more kick at those lower RPMs. And this is something that we're going to run into on a machine tool, either because of the mass of what you're trying to turn and get up to speed, or some cutting that you're doing at low speeds, okay? So this will really help us, all right? The adjustment range is 0 to 4, okay? And they give you a warning here, a large parameter may damage the motor, and that's because it's going to give it more voltage at a lower speed, more voltage, more power, more heat. It's turning slow. You could overheat the motor, or possibly even burn it out if you overdo this setting, okay? And then they have a frequency here that will limit that torque compensation. So once you get above whatever you define frequency, it'll go back to the normal voltage curve, okay? So let's take a look at both of these. So we're looking for parameter 13. Okay, it's at 0 right now. Okay, let's start slowly. Let's go to 1. Okay, now we're on parameter 14. Let's take a look at what that's set at. 80. Okay, let's lower that down. So we don't need our torque boost that high. Probably 30 hertz is probably plenty sufficient. There we go. Set. All right, let's try it. All right, here goes nothing. Okay, didn't like that. We went to overcurrent right away. Okay, so we have a value of 1. Let's lower that down. Let's try 0.5. Set. Yeah, that had a pretty good kickstart. Okay, let's slow it down. I'm surprised that that small amount of adjustment Okay, let's try something. Let's put this at 35 hertz. Stop it. Okay, we're still coasting to stop. We gotta make sure we go back and change that setting. So I put our ramp to stop setting back to ramp to stop, so it'll deaccelerate when we hit stop. Okay, and I've also put us back to 60 hertz. So let's do a test here. We're going to let it come up to speed, and then we're going to hit reverse. And this is still with the torque boost settings the way we left it. Okay, here we go. Okay, going to hit reverse. Okay, I don't see any issues there. Okay, I'm going to try turning that torque boost up just a little bit off camera. Okay, I raised that torque compensation to 0.7. We were at 0.5. Let's see what happens. Okay, we made it up. Made it full speed, no problem. Reverse. All right, stop. Okay, I think we're going to leave that there. If we don't have anything connected to the motor, if we had it connected to a machine, we'd get a better feel for how that torque compensation is helping us. But I think we're just going to leave it right there. It's probably a good starting point. All right, I've just been letting it run for a while, and so far so good. One test that I want to try that's important for us is what happens on a power failure. Okay, so I've got, you can't see it, but I got a power switch off camera here. I'm going to go ahead and kill power, and we'll see what happens. Here we go. Okay, power's off. LU-R. I'm assuming that's going to be a low voltage warning. Steady state under voltage. Okay, check voltage of power source. Okay, yeah, it's off. All right. Okay, so here's what you don't want. You don't want it to come back on by itself on when the power restores. Okay, so here we go, restoring power. Okay, I like that. Now there is a setting where you can change what happens on a power outage. It's parameter number 34, auto recovery. 0 is disable this function. I'm assuming that's where it's set. Let's take a look. So, yeah, 0, okay. Now let's hook up some external controls to it. So how do you wire up an emergency stop, aka e-stop, to a drive that doesn't have a provision for that? Let me zoom in on the wiring diagram. Sometimes you'll have a programmable input where you can go into the configuration and program it for something like e-stop, but this one doesn't have that. But what it does have is all the different control possibilities. They all wire back to one common point here, the ground connection. Okay, so all you got to do, you just cut in an e-stop switch here. That will basically disconnect that wire right there. Okay. Okay, so we want to use the normally closed. So under normal conditions, we have a closed circuit. Okay. If somebody hits the e-stop, that's going to open up. It's going to break power to all the various remote control inputs, and that will cause the drive to stop. Okay, so let's wire that in. Okay, I recommend this type of a switch where it has 3 positions, center being off, and I've already labeled forward and reverse here. Okay, so within the center position, I've got a switch on each side. You can see both of these are down. Okay, if I go to forward, this one is up and it's made. Okay, and if I go the other way, reverse, now that one's made. Okay, so forward is this guy, that's our brown wire. This side, we've got both of them jumpered together, connected to our black wire. So our black wire is going to go to our common, which is going to be the other side of our e-stop. Okay, and then we said our brown was connected to the forward side of our start-stop switch. Okay, so we're going to take the brown. On this terminal strip, it's labeled forward. Okay.
And it's right here. There we go.
Okay, and then our green one, just to verify, reverse, green, yep, okay. That one's going to go in reverse.
Reverse terminal.
All right, next is going to be our jog button, and this is just a momentary type operator and normally open contacts. It's got to connect to through our e-stop, just like the other one. And then this guy goes to D2 jog. Let's hook power back up, and we're going to try this. All right, I'm leaving the cover off this time because we've already run it. Nothing blew up. Hopefully nothing will blow up this time. All right, power on. Okay, now I have to change parameter, looks like number 4, to enable the remote switches. Parameter 4, set, and I think we want a value of 2, right? External signal for runtime, yep. 2, set, there we go. Let's try it. First of all, let's see what happens if we try to use our original controls here. Okay, start. Okay, nothing. Okay. All right, well, that's encouraging. In frame, yep, okay. Here we go with forward. Nice. Back to center, stop. Reverse. Sweet. And then direct from reverse to forward. All right, okay, back to stop. Okay. This one I'm not sure about, so this is our jog. Let's see what happens. Okay, nothing. All right, we're gonna have to do a little more investigating. Okay, let's go back to this one, forward. E-stop. There we go. Reset. Okay. Reverse. E-stop. Okay. Release. That is one bad thing. If you release your E-stop and you're still set for forward or reverse, it's going to go. Okay, so it'd be better if it had a separate e-stop where you could actually require a manual reset, but we don't have that. Okay, let me see if I can figure out why the jog doesn't work. I did quite a bit of off-camera research and testing to see if I can get this jog button to work, okay? So long story short, and here again, this is just a basic drive. It doesn't have a lot of programming features, okay, or functions. So there's only one mode it will work in, the jog button that is, as per the factory wiring showing the jog button connected here, okay? And that's in the incremental mode. So I've got it in the incremental mode right now for speed, and what that means, it requires an external momentary contact, and you can see I got a little push button wired up here. This would be for the slowdown, and then you'd wire another push button which wires very similar to the jog button for a speed up, okay? Now what I did find is the jog button will work as a speed up when you're in a normal run mode, okay? So let me just demonstrate that real quick. Okay, right now we're stopped, and let's try the jog button. Here we go. And as you can see, the jog function works fine, okay? And you got to put a jumper in here so you can you can determine whether you want it to jog forward or jog backwards based on that jumper, okay? We won't go any farther into that. Okay, now if you put it into normal run mode, now you have to use two push buttons, one for speed up, one for slow down. So this one I got wired for slow down. So every time you press it, it slows down a little bit. Might be kind of hard to sense that on camera, but it's slowing down every time I push that, okay? All right, and then the jog button now is the speed up button. So it's speeding up, speeding up. Okay? And then if we shut it off and use our jog button, it's back to being a jog function, okay? Yeah, I know that might be a little complicated. It does work. I don't want to go any deeper into this configuration because most of us probably aren't going to want to control it that way. Most of us are going to want to use a regular speed pot or the speed pot that's on the drive itself. Okay, but anyways, it does have that capability. Now I might try something else with this jog button. So let's continue on. We're going to hook up our remote speed potentiometer, and it says here, I don't know if you guys can see that or not, 1 to 5K ohms. So this is a 1K ohm, should work good. And let me hook this up off camera and then we'll take a closer look at those connections. So our connections are, we have to use the ground, and it's the same ground that we use for the switches. And by the way, this terminal strip on here is a very good quality. Very solid connection, and it looks like it's a Phoenix, you know, a standard commercial type terminal strip, very good quality. I've got the right side of the potentiometer connected to our ground terminal. The center wiper is connected to 5 volts in, and the green, which is actually our positive, I know, bad choice of colors, it's on the 5 volts out, okay? Okay, we've got our potentiometer hooked up, so now we have to change our speed frequency input selection. You would think it would be the one that says potentiometer, but I have a suspicion it's this one, external 0 to 5 volt, okay? I think this one is the panel potentiometer. So let's go to that. It's parameter 3. There we go. Okay, we're on 6 right now. Let's change that to 3. Okay, set. All right, let's see what happens. Let's see if it'll start with our switch. That still works. And let's see what happens when we adjust our potentiometer. Hey. Okay, that works just the way it should. Alright, this is not ideal, but it is a way that you could rig up a jog switch when configured for potentiometer speed control. Okay, all I did was rewire the push button switch so that it's in parallel with the normal forward mode on our normal control switch. So what you'd have to do is make sure that you have your speed turned down, because it's going to try to go to whatever speed you've got your speed set at. And with a momentary, you know, it gives you a little bit more control than a hard switch. And you could mount this, you know, in a different location. So if you're working on a lathe and you're trying to indicate or check run out and you want to use the jog, you may want this near the headstock rather than like on the carriage or something. So that is an option. Not ideal, like I said. Okay. All right, just a few other things. You probably noticed you hear the fan turning on and off. So the cooling fan runs whenever the drive runs. It's not thermostatically controlled that I can tell. And it does blow quite a bit of air. It's a pretty strong fan. To run over speed, you generally leave the motor rated frequency, which is the nameplate frequency of your motor, as per the nameplate. In this case, it's 60 hertz. Okay, so we're gonna change the maximum runtime frequency, parameter 10. We're at 60 right now. Let's see if we can get there. Parameter 10. By the way, you can just hold these buttons down and it'll go, rapid cycle. 10 set. Okay. So instead of 60, let's go 150%. So that would be what, 90? 90. Okay. Set. And this is where you got to know your motor, right? What can the motor handle? This is a 1765. So 1800 RPM, base speed motor. Usually you can run those at double speed. I like to be a little cautious and only go 150% of the speed rating. But if you check with your motor manufacturer, good luck on that. But they can probably tell you what your maximum speed is. You don't want to exceed that. Okay, so let's go ahead and test it. Okay, on. So 28 hertz, 50 hertz, 60. That was our original full speed. 66. 74, 82, 90 hertz. Okay. Now, that's how I run my South Bend lathe. I've got a drive on it. I think I only max out at 80 hertz. But that allows you to extend your gear selection range, if you will. I mean, the South End's a belt drive, so rather than having to keep changing belt pulleys, I can run it at what would normally be a lower speed, but by overspeeding the motor, I can get a wider speed range without having to change my belts, if that makes sense. All right, well, I'm going to go ahead and wrap up the testing. I'm going to disconnect everything, and I'll meet you guys back over at the table, and we'll talk about how you can win this drive in a giveaway. So I'll see you there in a minute. Okay. Well, congratulations if you made it this far, guys. I know that was quite a bit of things we covered there. Yeah, so overall conclusion is, I mean, for the price, geez, it's hard to beat this thing. It is very basic as far as what you have for settings, but it does the job, okay? The instruction manual, it's a little confusing in some spots, but it's workable, all right? We did have an issue with the display. I wanted to try to remove the display and use it remotely with the supplied cable, but it's really in there tight, and I don't want to break it because I want somebody to win this and have it in undamaged condition. So how to win this thing? All right, so unfortunately, I can only ship this to USA addresses. Shipping costs are just ridiculous anymore. So if you're in the USA or a USA territory, you're good to go. It would be nice if you were a subscriber to the channel, but I won't hold you to that. So all you got to do, just leave a comment down below. And somewhere in your comment, just put the 3 letters VFD, uppercase, lowercase, I don't think it matters. I do uppercase, but just put VFD somewhere in your comment, and you're in, okay? As long as we can ship to a U.S. address, okay? Yeah, if you're outside of the U.S., it would be cheaper just to buy one from Vevor directly. They ship all over the world, and just the cost of shipping alone, if I tried to send this to you, would be probably more than what you would pay for the drive if you just bought it outright. Okay. All right, yeah, so I mean, we beat on this thing pretty good. We didn't get any magic smoke. It's still running. So, I mean, yeah, what else is there, right? So, yeah, I'm pretty impressed. Okay. Anyways, I'll put a discount code down below and a link to the website where you can get to this on Vevor. And thanks again, everybody, for watching the review and sticking with it. And we will see you guys soon. Oh, wait a second. I'm going to include all these switches, all right? So whoever wins, you get all this stuff also. I've got plenty of miscellaneous stuff like this. So and it's all wired, ready to go. I mean, I unhooked it, but I'll include a little hand-drawn drawing on how to hook everything up. You may or may not want to use these parts, but at least it'll give you a guide to get you started. Okay. All right. So what we'll do is in probably 2 weeks, 2 to 3 weeks, we'll do another video with the winner, and you know, good luck, and hopefully you'll be the winner. All right, guys. Thank you, and we will see you on the next one. Bye.